FractureSpark allows interpreters to quickly and accurately visualize the discrete fracture network in unconventional plays. FractureSpark workflow starts by defining fractures. In this example, we have seismic amplitude data from the Niobrara Formation. Here the interpreter uses horizon edge stack volume, tuned for fractures and co-rendered on the Niobrara surface. FractureSpark images both through-going faults as well as fractures. Once the fractures have been defined, the interpreter uses the FractureSpark workflow to create an enhanced fracture density attribute volume. Here the volume is co-rendered on the Niobrara surface and the enhanced fracture density area is highlighted in the red oval. FractureSpark helps interpreters find the sweet spot for tapping the formation for optimal drainage and identifying target intervals for zonal completions. Here we see a straddle slice of instantaneous amplitude attribute volume at the Niobrara Formation surface. FractureSpark helps interpreters correlate and calibrate with well control. Here is the enhanced fracture density attribute correlation with well brittle zones from log analysis. With FractureSpark, interpreters can visualize time-lapse display synchronized with the pressure, flow, and proppant concentration parameters of the frac job. Microseismic and seismic data can be displayed together with 3D visualization, including glyphs and transparency. Here the interpreter views shale spark pump curve in Fracture Simulation Viewer. FractureSpark helps interpreters visualize core fracture planes. FractureSpark allows interpreters to visualize the discrete fracture network, then use fracture azimuth data to recommend the ideal path for directional drilling. So with FractureSpark, you define the fractures, determine the sweet spot, then drill with confidence. FractureSpark has been used in several unconventional plays. Here are a few North American projects and the role FractureSpark played in their success.